Hello students. Welcome to Swami Vivekananda Group of Institutes, the official YouTube channel of Sri Ramakrishna Institute of Science and Technology and Swami Vivekananda Institute of Science and Technology. In today's video, we will discuss about electric charge. The knowledge of electric charge is very important to go further into the topic of electrostatics, which is the third unit of the subject, Applied Physics 2, under the Diploma course in the first year, second semester. So, without any further delay, let's jump into the discussion. Let us divide this lecture into 4 categories. First, we will go through some introductory concepts of electric charge. Then we will discuss the historical developments related to electric charge. Next, we will try to explain frictional electricity based on atomic structure. And finally, after developing basic knowledge, we will discuss more about electric charge. Suppose we take a glass rod and a piece of silk cloth. We rub the glass rod with silk. Now, we take an ebonite rod and a piece of flannel cloth. We then rub the ebonite rod with flannel. In doing so, we find that both the glass rod and the ebonite rod acquire power to attract light bodies, such as small pieces of paper. So, we can say that there is some agency which is providing this attracting power to these objects. We term this agency as electricity. The bodies, that is, the glass and ebonite rods, are said to be electrified or charged because they have acquired this power. We know that rubbing causes friction, and since we have rubbed both the rods with silk and flannel respectively, hence we can say that the power is developed due to friction. So, we term this phenomenon as frictional electricity. We need to remember that frictional electricity is caused by the charges that are at rest. That is why frictional electricity is also termed as static electricity. The branch of physics which deals with static electricity is called electrostatics. Let us now discuss the historical development of electric charge. These are the 3 most important persons who have enormous contribution in the development of electric charge. The first person is Thales of Miletus. He was one of the founding fathers of Greek science. The second person is William Gilbert. He was the personal physician to Queen Elizabeth I of England. And the last person, but not the least, is Benjamin Franklin. He was an American scientist-statesman. It is believed that, around 700 BC, Thales of Miletus observed that amber, when rubbed with wool, is capable of attracting light objects, such as small pieces of paper, bits of straw, etc. So, we can write the observation as, amber, when rubbed with wool, can attract light objects, such as pieces of paper, bits of straw. Science of electricity has its roots in this observation. Electron is the Greek name for amber. Check out the spelling of the word electron. That is how the word electricity came into use. This is also the origin of the words electric charge, electric force, and electron. In the year 1600 AD, Dr. William Gilbert, in his book, De Magnete, which means on the magnet, gave the first scientific account of the early experiences of electric and magnetic effects. He found that many other materials, such as glass, ebonite, sealing wax, etc., behave like amber when they are rubbed with suitable materials. He introduced the name electrica for substances like amber. In his book, he also stated that 2 kinds of electricity are produced in all experiments of frictional electricity. He stated that electric charges of same kind repel each other, while those of opposite kinds attract each other. He named the 2 kinds of electricity as resinous and vitreous. According to him, the kind of electricity developed on amber, when rubbed with wool, was called resinous. This name was probably given due to the fact that amber is a resin. And the kind of electricity developed on wool was called vitreous. In 1750 AD, Benjamin Franklin introduced a convention of electric charges. According to this convention, if a glass rod is rubbed with wool, the kind of electricity that appears on the glass will be called positive. On the other hand, if an ebonite rod or amber is rubbed with wool, the kind of electricity that appears on either ebonite or amber will be called negative. So, vitreous became positive, while resinous became negative. This convention has ever since been followed. The property which makes the two types of charges distinguishable is known as the polarity of charge. Let us now explain the phenomenon of frictional electricity based on the atomic structure of atoms and electron transfer. The frictional electricity can be understood by considering the structure of an atom. An atom consists of a central nucleus containing protons and neutrons, with electrons revolving round it in different fixed orbits. Protons are positively charged particles, while electrons are negatively charged particles, and neutrons are neutral particles. Let us consider one such atomic structure of a substance, say, A. Every atom is held together by the electrostatic attraction between the positively charged nucleus and the negatively charged electrons. Within an atom, the electrons closest to the nucleus are the most strongly held, whilst those further away experience a weaker attraction. Normally, an atom contains the same number of protons and electrons. According to the diagram, the atom has 11 protons and 11 electrons. This means that atoms are normally neutral because they have the same number of positive and negative charges. Since all objects are made up of atoms, and since atoms are normally neutral, objects are also usually neutral. Let us now consider another substance, say B. We consider it has 7 protons and 7 electrons. So, both the substances, A and B, are electrically neutral. However, when we rub two substances together, the friction can cause electrons to be transferred from one object to another. We must remember that the protons are fixed in place in the nucleus, and so they cannot be transferred between atoms. It is only electrons that are able to be transferred to another substance. Some objects give up electrons more easily than other objects. In our present example, it is the substance A which gives up one electron easily. This electron is transferred to the substance B. Now the atom of the substance A has one electron fewer than the total number of protons, while the atom of substance B has one electron more than the total number of protons. So, the substance A becomes positively charged, while the substance B becomes negatively charged. So, we now understand the transfer of electrons that takes place as a result of friction between objects. Now, we will do one simple activity, and we will try to explain the outcome of the activity based on the knowledge we have just gathered about the frictional electricity. Suppose we have a glass rod and a piece of silk cloth. Initially, both the substances are neutral. Now, we rub the glass rod with the silk cloth. After rubbing, we find that a net positive charge has appeared on the glass rod, while a net negative charge has appeared on the silk cloth at the same time. The amount of positive and negative charges on the glass rod and the silk cloth are the same. Let us try to explain the result. When we rub the glass rod with the silk cloth, there is mechanical friction between these two objects. Due to this, some of the electrons are torn off from the atoms or molecules in the glass. Now the question is why? This happens due to the fact that electrons are held less tightly in the glass than in silk. So, the electrons which are torn off are immediately transferred to the silk cloth from the glass. As a result, there is now excess of electrons on the silk cloth, and these excess electrons appear as the net negative charge on the silk. Simultaneously, deficiency of electrons is created in the glass rod. This deficit of electrons in the glass rod makes it positive by an equal amount. So, from this activity, we can conclude that when certain materials are rubbed against each other, they tend to lose or gain electrons, thus acquiring positive and negative charges. Till now, we have gathered knowledge on the historical developments of electric charge. We have explained the frictional electricity based on the atomic structure, and we have applied this understanding to explain a real-life activity. Now, we will discuss more about the electric charge. Let us now define electric charge. Electric charge is something possessed by material objects. So, we say that electric charge is a characteristic associated with matter, and it is responsible for the magnetic and electrical effects produced and experienced by matter. For example, the sensation of a mild electric shock that we feel while turning on a tap or opening the door of a car is caused by the discharge of electric charges which have built up due to friction between two surfaces. We have learned that when two objects are rubbed against each other, one of them acquires a net positive charge, while the other object acquires a net negative charge of the same amount. Now, the electric charge in ordinary materials is transferred by the exchange of electrons. So, we need to think the electric charges based on the number of electrons that is transferred between objects. This leads to the next topic, quantization of charge. Before start discussing this topic, first let us know what is the meaning of the term quantization. Suppose there is a physical quantity which can only assume values that are integral multiples of a small reference quantity. When this happens, we say the physical quantity is quantized. Experiments have shown that the smallest amount of charge that can exist in nature is the charge carried by an electron or a proton. Its magnitude is 1.602 into 10 to the power minus 19 coulomb. Since all these charge transfers are associated with the transfer of electrons, all charges on an object must be a multiple of the said value. So, quantization of charge simply means that when we say some object has a given charge, we mean how many times the charge of a single electron it has. If we denote this smallest charge by the letter small e, the charge possessed by an object can be expressed by the equation Q equals plus minus n times e, where n is an integer having values 1, 2, 3, and so on. The plus sign indicates deficiency of electrons in an object, while the minus sign indicates excess of electrons in an object. So, it is clear that charge is quantized because only an integral number of electrons can be transferred from one object to another. So, quantization of charge tells us that when we have a charged object, charge on that object can only be like E, 2E, 3E, and so on. But charge on an object can never be like 1.75E, 2.2E, 0.7E, and so on. Remember, the quantization of charge has a meaning only at the microscopic level, at which the amount of charge, or the number of charged particles involved, is small and countable. At the macroscopic level, the value of charge appears to be continuous, though the transfer of charge still takes place in integral multiples of one electronic charge. Next, we will discuss conservation of charge. The law of conservation of charge is the basis of many equations of electricity and magnetism. It is an exact law of nature. We must remember that charge can neither be created nor destroyed. This means, if a certain quantity of positive charge appears or disappears in an isolated system, an equal quantity of negative charge must appear or disappear simultaneously and vice versa. So, the statement of the law can be written as, total charge of an isolated system is conserved. So, the algebraic sum of positive and negative charges in an isolated system remains constant. No charge can get into or go out of the system. However, within the system, interactions between different bodies of the system can cause transfer of charge between them. For example, when a glass rod is rubbed with silk, same amount of negative and positive charges appear on silk and glass, respectively. But the net charge on the glass-silk system remains zero, both before and after rubbing. We have seen that there are two kinds of charge, positive and negative. Let us do one simple activity to get one of the fundamental properties of electric charge. Suppose we have a pair of glass rods on our left and a pair of ebonite rods on our right. We rub the two glass rods with silk and the two ebonite rods with flannel. Now, if we bring those two glass rods close to each other, we find that they repel each other. Similarly, when we bring those two ebonite rods close to each other, they repel each other, just like the glass rods. However, when we bring one of those two glass rods and one of those two ebonite rods close to each other, they attract each other. This suggests that the charges on the glass rod and the ebonite rod are of different natures. The ebonite rod is said to have acquired negative charge, while the glass rod is said to have acquired positive charge. So, we conclude that like charges repel each other, and unlike charges attract each other. Let us now write down the properties of electric charge. Number 1. Charge is a scalar quantity and is of two types, positive and negative. Number 2. A body is said to be positively charged if it has a net positive charge. Similarly, a body is said to be negatively charged if it has a net negative charge. Number 3. Like charges repel each other, while unlike charges attract each other. Number 4. Charge is quantized and conserved. Number 5. As we can add charges algebraically, charges are additive in nature. Number 6. Charge cannot exist without mass, though mass can exist without net charge. That is why photons never possess charge, as they have no rest mass. Number 7. As a body gets charged, its mass changes. Because excess or deficiency of electrons cause this change of mass in the body. Number 8. When a charged particle is at rest, it produces an electric field around it. But when the charged particle is in motion, it produces magnetic field, in addition with electric field around it. Number 9. Accelerated charges radiate energy in the form of electromagnetic radiation. We have already seen that we can charge different bodies by rubbing them against each other. This is known as charging by friction. Now, we will learn charging by induction. The process of charging an uncharged body without bringing a charged body in actual contact with it is known as charging by induction. Suppose we have a neutral body, XY, placed on an insulating stand. When we bring a positively charged body, say, C, close to it, the charged body attracts opposite charges and repels similar charges present in the uncharged body. As a result, the X end of the body becomes negatively charged, and the Y end of the body becomes positively charged. The charges at the end X are known as bound charges, because they are bound by the attraction of the charge on C. The charges at the end Y are known as free charges, because they are free to move farther away from C. If the body is now earthed, keeping C in place, the charge at the end Y will appear to be leaving the body. But in reality, positive charge cannot be moved out of the body. What actually happens is, since there is a deficiency of electrons at the end Y, electrons from the ground enter the end Y and neutralize the accumulated positive charges there. If C is now moved away, the charge on XY spreads throughout its surface, and thus making it negatively charged. The charge on C is known as the inducing charge, and The charge developed on the conductor XY is known as the induced charge. Remember, if there are electrons at the end Y, they will enter the ground when the body is earthed. So, students, this concludes today's lecture on electric charge. See you in the next video.